Hi, I'm Patrick Reagan. Welcome to the TCP/IP Part 15, Placement and Security of DNS Services. This continues our discussion from the last two videos on DNS services. During this video, we'll discuss where you should place your DNS servers, when you should use cloud DNS services, and how to establish security for DNS. If you like this video, be sure to click the like button. If you have not already, subscribe to the Pat Has Your Back channel. In a SOHO network, you don't typically have a server infrastructure. Instead, your wireless router or switch will provide DNS services and will forward to your ISP DNS or to an Internet DNS. The DNS settings for the wireless router or switch may be automatically configured from your ISP DHCP services, or you'll have to specify the DNS server settings. The router or switch can also provide DHCP services that will hand out DNS settings to your client as part of to perform automatic IP configuration. For larger organizations, you want to separate internal DNS servers from external servers. Internal DNS will resolve internal resources such as Internet and application servers and to forward to the Internet DNS servers for clients to access Internet resources. Internal user and services will use the internal DNS servers. External DNS servers allow public users to find your websites and mail servers. External DNS servers will be found in the DMZ or screen subnet. You want to keep the internal DNS private because you don't want it to be used by hackers to find your internal resources and to trick users to go to sites that would compromise the network and their systems. If you are a small company with several servers, you want to place two internal DNS servers in your server room to service your client computers and internal servers. You should consider using two or more DNS servers for fault tolerance in case one goes down. Typically, these will be on two separate physical servers or within two virtual machines, each located on different physical hosts. The internal DNS servers will be configured to forward to an ISP or internet-facing DNS server. If you don't want to use forwarders, the DNS server will perform recursive resolution as needed by starting with the root servers. Traditional DNS servers were based on primary and secondary servers. Primary DNS servers contain all relevant resource records and handles DNS queries for a domain. Secondary DNS servers contain zone file copies that are read-only, meaning they cannot be modified. Instead of getting their information from local files, they receive pertinent information from a primary server in a communication process known as a zone transfer. DNS zone transfers are used by primary and secondary DNS servers to update zone files and records. Two types of DNS zone transfers are: the authoritative zone transfers entire zone even if only one record changes, while the incremental zone transfers only the changes will be transferred. For using Windows Server Domain Controllers, DNS is tightly integrated with the Active Directory so that users can find and use the directory services. If you have more than one domain controller, there's no reason not to use Active Directory integrated DNS zones that allow all servers to act as a master DNS server that will replicate any changes to any other DNS servers. The external DNS servers will not have DNS resource records for internal resources. It will have DNS entries for public internet users to find your external websites, such as your websites and your receiving email servers, so that mail can be delivered to them for your domain. Instead of hosting your own external DNS servers, you can use your domain registry services such as Google Domains or GoDaddy. For internal DNS, for organizations that have multiple sites, you should consider having at least one domain controller for each site and two for the data center. DNS servers at the other sites can act as backups to the local DNS. It should be noted that your data center could be located in the cloud, whereas you're utilizing various cloud services, including hosting virtual machines in the cloud. Same rules apply where you can add your internal DNS and/or external DNS within the cloud, just as if you're part of your network. Using external DNS services like GoDaddy or Google for domain name resolution offers several advantages. Reliability and uptime. External DNS providers, especially well-known like Google or GoDaddy, usually have robust infrastructure with global data centers ensuring high availability and uptime. This can reduce the risk of DNS outages affecting your site. Global distribution. These services typically use globally distributed DNS servers, including anycast networks, which can improve query resolution speed and reduce latency for users accessing your website from different geographical locations. Security features. Many external DNS services provided advanced security features such as DNSSEC, distributed denial of service protection, and phishing and malware defenses to ensure secure resolution and prevent attacks. Cost-effective. External DNS services can be more cost-effective than maintaining an in-house DNS infrastructure, particularly for smaller businesses that do not have resources to manage their own DNS servers. Ease of use. Platforms like GoDaddy and Google often provide user-friendly interfaces for DNS management, making it easier for non-technical users to configure records such as A, CNAME, MX, and text records without needing deep knowledge of DNS. No worry of zone transfers. When using external DNS services, you don't have to worry about configuring primary and secondary DNS servers and configuring zone transfers between the DNS servers. Scalability. External providers can handle sudden spikes in traffic more easily due to the robust infrastructure, making them ideal for businesses that might experience varying traffic load. Forwarding. Some external DNS servers, such as GoDaddy, allow you to redirect your domain or URL to another site or page. If an intruder infiltrates a DNS system, they can send users to fake or malicious sites, or they can also steal data, hijack websites, or inundate servers with requests as part of a denial of service attack. Domain name system security refers to the techniques to defending DNS infrastructure from cyber attacks. It ensures your DNS infrastructure is operating efficiently and reliably. Be sure to establish redundant DNS servers. Consider using load balancing to route DNS requests to healthy servers when one begins to perform poorly. For public-facing DNS servers, make sure you have a DNS firewall that helps protect your DNS servers, including providing rate-limiting services to shut down attackers trying to overwhelm the server. Use security technologies like domain name system security extensions or DNSSEC, and mandate stringent DNS logging. DNS security extensions or DNSSEC protects against attacks by digitally signing data to help ensure its validity. In order to ensure secured lookup, the signing must happen at every level in the DNS lookup process. This signing process is similar to someone signing a legal document with a pen. That person signs with a unique signature that no one else can create, and a court expert can look at the signature and verify the document was signed by that person. These digital signatures ensure that the data has not been tampered with. You should deploy DNSSEC when you need to ensure that the authenticity and integrity of DNS responses, especially for public-facing domains or environments with high security requirements. In Windows, it's easy to sign a zone. Just right-click a domain and click DNSSEC and click Sign the Zone. You can then customize zone signing parameters, use settings from another zone, or use the default settings. A lock appears for the zone, indicating that the zone is signed. A bunch of DNS resource records are added to the zone. In most cases, you should not deploy DNSSEC for your internal enterprise domain. There's no trust chain with private zones because internal domains are not part of the public DNS hierarchy, so there's no parent zone to publish DS records, breaking DNSSEC validation. DNSSEC adds complexity without real gain, particularly if your internal environment is already protected by AD integrated DNS, mutual authentication such as Kerberos, internal firewalls, and controlled resolvers, making DNSSEC redundant. Microsoft DNS does support DNSSEC, but is designed for publicly resolvable zones, and AD integrated DNS doesn't benefit from DNSSEC. DNSSEC has high operational overhead, with key signing, rollover, and zone signing automation requires time and tools that most internal DNS solutions don't handle elegantly. DNS does include breakage risk increases, which a failed signature or expired key in DNSSEC can break name resolution entirely, impacting business-critical internal services. There's no client-side validation for internal clients, unless explicitly configured, which is rare, making the benefits mute. DNS has internal resolver control because you own both authoritative and recursive DNS infrastructure internally, allowing you to trust the system without DNSSEC validation. You may consider using DNSSEC internally if you're operating a secure enclave or classified network. DNS requests and responses are sent in the clear, which allows anyone to view the traffic, which is a security and privacy concern. DNS over HTTPS, or DOH, and DNS over TLS, or DOT, are both methods for encrypting DNS queries, essentially hiding what websites a user is trying to access, but the different in how they achieve this encryption by using different network layers. DNS over HTTPS encrypts DNS requests within standard HTTPS traffic using port 443. It is harder to block or filter by ISP because it blends in with regular HTTPS traffic. It provides better privacy by hiding DNS traffic within normal web traffic. It is often preferred for consumer-level devices and browsers. DNS over TLS, or DOT, encrypts them directly at the transport layer using TLS protocol over port 853. Provides a dedicated port for encrypted DNS traffic, making it easier to manage. It is favored for network administrators who want clearer control over encrypted traffic. It is preferred in enterprise or managed environments where stricter network traffic segmentation is needed. Some cloud-based security platforms such as Cisco Umbrella, Cloudflare Gateway, and Zscaler Internet Access, or ZIA, provides a comprehensive protection against internet-based threats, including malware, phishing, ransomware, and other types of cyber attacks, including DNS layer security. Designed to safeguard users whether they're inside or outside the corporate network, offering secure access to the internet and enforcing security policies without requiring hardware or on-premises solutions. When a user tries to access a domain, the cloud security service that has DNS layer security checks the domain safety before allowing the connection. It blocks requests to malicious or harmful domains, such as those hosting malware or phishing sites at the DNS level, often stopping threats before they even reach the network or device. When implementing such security, you would point your client DNS servers to a vendor's DNS server or agent running on the user's device, which will forward to your company's DNS servers as needed. By going through the vendor's DNS server, each name resolution query will perform threat intelligence checks and take action against threats. DNS poisoning, also called DNS cache poisoning, occurs when an attacker injects malicious or false DNS data into a DNS resolver's cache. As a result, users trying to visit a legitimate website are redirected to a fraudulent or malicious site controlled by the attacker. This can lead to phishing attacks, malware distribution, or data theft. DNS spoofing, or DNS response spoofing, happens when an attacker intercepts DNS queries and provides fake responses, redirecting users to malicious sites. Unlike poisoning, spoofing usually occurs in real time and doesn't rely on cache data. By combining secure DNS protocols, monitoring systems, and user education, organizations and individuals can significantly reduce the risk of DNS poisoning and spoofing attacks. To protect against DNS poisoning and spoofing, you should enable DNSSEC, which ensures the integrity and authenticity of DNS responses by adding digital signature to DNS records. It helps protect against tampered or spoofed responses. Implement Transport Layer Security, or TLS. DNS over HTTPS or DNS over TLS encrypt DNS queries, preventing attackers from intercepting and spoofing responses. Harden DNS servers. Configure DNS servers to prevent unauthorized access or tampering and use secure protocols to communicate between DNS servers. Cache management. Regularly clear DNS cache to minimize risks of poison entries persisting. Set a short time to live, or TTL, for DNS cache entries to reduce exposure to poisoning. Network security. Use firewalls to block DNS traffic from untrusted sources and monitor DNS traffic for anomalies that could indicate an attack. And user protections. Use a reputable DNS service provider such as Cloudflare or Google Public DNS that implement strong security features. Ensure end users' devices are patched and protected with antivirus solutions. Regularly monitoring. Employ intrusion detection or prevention systems to identify suspicious DNS activities. Use DNS logging and analysis to track and respond to abnormal queries. Employee training. Educate users to identify phishing attempts or unusual website behaviors that may result from DNS spoofing. Question: where would you locate an external DNS server? Answer: DMZ. Question: you are reviewing log files after a third party discovered usernames and passwords for the organization's accounts. You also see there was a change in the IP address for vendor website 1 week earlier. This change lasted 8 hours, which the following text was most likely used. Answer: DNS poisoning. Question: you want to ensure the organization's validating and checking the integrity of zone transfers. Which of the following solutions should be implemented? Answer: DNSSEC. Question: you receive alerts about an internal system sending a large amount of unusual DNS queries to systems on the internet over short periods of time during non-business hours. Which of the following is most likely occurring? Answer: data is being exfiltrated. Question: you have a company's public-facing website at https://www.website.com, which has an IP address of 176.18.35.25. However, over the past hour, the SOC has received reports of the site's homepage displaying incorrect information. A quick NS lookup search shows https://www.website.com is pointing to 161.121.142.145. Which of the following is occurring? Answer: DNS spoofing. Question: when internal users attempt to access the company's website, they are redirected to an inappropriate website. Which of the following is the scenario an example of? Answer: DNS poisoning. For more information, refer to these sites. In summary, for larger organizations, you want to separate internal DNS servers from external servers. Internal DNS will resolve internal resources such as internet and application servers and forward to the internet DNS servers for clients to access internet resources. External DNS servers allow public users to find your websites and mail servers. For using Windows Server domain controllers, DNS is tightly integrated with the Active Directory so that users can find and use the directory services. You should consider using 2 or more DNS servers for fault tolerance in case one goes down. External DNS servers allow public users to find your websites and mail servers, External DNS servers will be found in the DMZ or screen subnet. Instead of hosting your own external DNS servers, you can use your domain registrar services such as Google Domains or GoDaddy. DNS security extensions or DNSSEC protects against attacks by digitally signing data to help ensure its validity. DNS over HTTPS or DOH and DNS over TLS or DOT are both methods for encrypting DNS queries, essentially hiding what websites a user is trying to access, but they differ in how they achieve this encryption by using different network layers. DNS poisoning, also called DNS cache poisoning, occurs when an attacker injects malicious or false DNS data into a DNS resolver's cache. DNS spoofing or DNS response spoofing happens when an attacker intercepts DNS queries and provides fake responses, redirecting users to malicious sites. Thank you for watching this video. The next video will be TCP/IP Part 16, Configuring and Troubleshooting Client DNS. If you like this video, be sure to click the like button. And if you have not already, subscribe to the Pat Hedger Back channel. Thank you.